Hey guys, Tutor Titan here. Hope all is well with you. This is going to be our first video to the financial math section, and we're going to be discussing the topic around the time value of money. Okay, and some of you might get exposed to this in grade 11 math in geometric sequence and series. You might even get to see it in grade 12 math in the exponents unit. But for the most part, you're going to be seeing this in university finance classes, those first year courses. Okay, and if you guys have ever heard someone say, well, money today is worth more than money tomorrow, they're actually talking about the time value of money, okay? And the reason why they're saying that is because that money you have today, right? So you have $1,000, you could actually invest that money and generate some sort of return instead of just having it sit there dormant in your account, right? You might as well just invest it, right? And the easiest way to sort of think about this is just think of opening a savings account, right? So with a savings account, my bank is going to promise me some sort of return by having my money there, right? And how are they even able to give me a return on that money in the first place, right? So banks actually run on a fractional reserve banking system, right? So say I put $1,000 in, they might actually only keep 100 of those dollars in the account, right? And they're actually loaning out that other 900 to different entities, right? And they're charging them actually a higher interest rate than what they're offering you, right? So they charge that entity that higher rate. They give you a lesser rate. They actually take the difference between those rates, and we call that like a spread, right? So now let's jump into an example here. So let's say we put $1,000 in to our savings account. Okay, the bank is promising us 5% per year, and it's compounded yearly. Okay, and then we're going to do this for 14 years. Okay, and essentially we're just going to calculate how much that $1,000 is going to turn into in 14 years, right? And a lot of you are probably wondering, like, what does this compounding thing mean, right? So compounding is actually referring to the reinvestment of that money, right? So when I put $1,000 in at 5%, I'm going to get $50 after a year, right? So instead of now having $1,000 in the account, I have $1,000.50, right? So now my bank's going to pay me 5% on 1,050 rather than 1,000, right? And that's going to go up each year, right? And it's going to compound on itself, right? So now let's just show the formula here. So we got future value, right? That's going to be how much that's worth in 14 years in this case. And then we got our present value, right? That's how much money we're putting in. Okay, so we're putting in the 1,000. And then 1 plus the interest rate, which we use R for that, divided by n, the compounding periods, right? So in this case, it's compounded yearly, so that's once a year, right? And then to the power of n times t, okay? And let's start plugging in the numbers here, but before that, t is actually just the amount of years, right? So don't forget that. And let's plug them in. So we put 1,000 in for PV, and then we get 1 plus 0.05 divided by 1 to the power of 1 times 14, okay? And now you probably see that I didn't use 5%, I used 0.05, right? So whenever we're doing calculations, we always convert percent to decimal, right? Otherwise, it's not going to work, okay? And always before we actually calculate all this, let's do it in parts, right? It just reduces the amount of errors that way, right? So I'm going to simplify what's in the brackets first. I get 1.05 to the power of 14, okay? And then when I plug this all in now to my calculator, I get a future value of $1,979.93, okay? So we can see our investment actually nearly doubled after that 14-year period, right? And just on a side note here, there's actually a formula they teach you in economics. It's called the rule of 70, okay? And it's kind of exclusive to economics. You don't really see this in finance too much, right? But basically it's telling us like how long is my investment gonna take to double, right? And it can use whatever interest rate. It's like how long will it take to double with that interest rate, right? And the formula for it is 70 divide interest rate equals the amount of years to double, okay? And if we use our example, okay, I'm gonna put in the 5%. In this case, it's weird, you don't actually need to do decimal, right? And we get 14, right? So that's kind of a cool little quick equation just to kind of get an estimate of where we are, right? But if you're always trying to be more exact, I would just stick with that FV formula, right? But this rule of 70 could be good to kind of quickly compare different rates, right, from different sort of investments there, right? And now let's just do maybe a bit harder of an example, okay? So that one's pretty easy, right, because compounding is yearly, right? So now let's say we put $1,000 in, okay, and we're still going to get that 5%. This time, though, it's compounded semi-annually, okay? And that means like twice a year, right? It's going to be compounded, right? One at the 6-month mark and then one at the end of the year, right? And we're going to do this time for 10 years, okay? So hopefully you guys remember the formula. We're going to be using the exact same one, right? We're just going to see how much this is worth in those 10 years, right? So FV equals 1,000, our present value, what it's worth today, times 1 plus our interest rate, again in decimal. And this time, instead of n being 1, it's 2, right? Because right? Semi-annually, twice a year now, we're compounding, okay? And that's to the power of n times t, which is 2 times 10, okay? Now let's plug this all in, and again, let's just first simplify it a little bit, just so we don't make some errors. And we're going to get 1,000 times 1.025 to the power of 20, okay? And then when we punch this all in, we get $1,638.62, okay? So that one's a little bit different now because we actually included this compounding period, right? So that's a little bit of a level up from the last question. And I hope these two examples are able to help you guys out in working through this stuff. It's honestly not too bad. And you got the formulas now, so you guys got this. Anyways, thank you for watching, guys. There's going to be plenty more math videos to come. Please subscribe. It would help me a lot. And if you guys need any tutoring, don't be afraid to visit my website at tutortitan.ca. Thank you. Bye-bye.